Okay, this is 6.3 homework help. The first problem wants us to find the cosine of pi over 2. So if we know our unit circle, we know where pi over 2 is, it's right here. The cosine of that is the x value, so that's just going to be 0. Now we want to find the cosine of 5 over 2 pi. 5 over 2 pi is 2.5 pi, so that means we'd go around once to pi, we'd go around twice to 2 pi, and then we'd go around it again another half pi. So 2.5 pi is actually around 2 plus another half pi back to this point, where we know the x value for cosine is 0 on the unit circle. Okay, so we want to do the same thing for the next problem. We want to find the exact value of the sine of 930. So we need to figure out where 930 is. So what I'm going to do is I'm going to divide 360 into it, or subtract 360 to find out what's left over. So if I subtract 360 twice, that leaves me with 210 left over. 210 is 180 plus another 30 degrees. So basically that means I'm here on the unit circle. So if I were to, graph this whole angle, what it means is I go around once, I go around twice, and then I go around one more time until I get to 210 right there. So I'm looking at this spot 210, and I know my values here for my special right triangles, or rather my unit circle, is negative square root of 3 over 2 comma negative 1/2. So I'm looking at that point, and they want the sines, they want the y value, which is negative 1/2. Next, they want the cosine of that same angle, so the cosine is then the x value, which is negative square root of 3 over 2. Okay, the next problem gives us this picture here, and it says point W is on the figure, and it says the angle is 330. So we're going to rotate around 330, and it's a little hard to see. I'll draw it a little bigger right here. Rotate around to 330, which is here, which leaves a 30-degree angle left over for our reference triangle right here. Alright, it says the radius is 8 right here as well, and it says give an exact answer, not a decimal approximation, for the point AB, including parentheses. So we're looking for this point right here. Now, there's different ways to do this, but the easiest way, I think, is to use our special right triangles. So I'm going to call the small side x, which makes the hypotenuse 2x right here, and makes the long leg x squared of 3. So we know that if 2x equals 8 right here, x must be 4. And so this must be 4 square root of 3 for the side length. So my ordered pair becomes 4 square root of 3 comma negative 4. The next problem says suppose an angle theta is in the first quadrant. So we know we're talking about this first quadrant between 0 and 90. And it gives us the cosine. So I'm going to draw a reference triangle in there and just label what they told me. They told me the cosine was 1/8, so that means adjacent over hypotenuse is 1 over 8. And they say find exact values for the following. We want cosecant. Well, first I'm going to find this side over here by using the Pythagorean theorem. If I do 8 squared equals 1 squared plus b squared and solve for b, I get 64 minus 1 square rooted, which is the square root of 63. So now I can find the cosecant. So cosecant is the reciprocal of sine. So instead of doing opposite over hypotenuse, I'm going to do hypotenuse over opposite. 8 over the square root of 63. And then cotangent is the reciprocal of tangent. So instead of doing opposite over adjacent, I'll do adjacent over opposite. Alright, the next problem wants us to determine any point in the third quadrant for which the tangent of alpha is equal to 6. So if the tangent of alpha is equal to 6, there's different ways to do this, but I'm going to call opposite over adjacent 6 to 1, because that would give me a tangent of 6. And then I can do the Pythagorean theorem to find the hypotenuse. That'd be 36 plus 1 square rooted, so it'd be the square root of 37 for the hypotenuse. So one valid point in the third quadrant for which tangent would be 6 would be negative 1, negative 6, because I would go back negative 1 and down 6. And then if I want the sine of this angle would be opposite of our hypotenuse, so it'd be 6 over the square root of 37. Now, I know my angle is actually this right here. That's my actual angle alpha. But it doesn't matter. I use this reference triangle for that angle. Make a reference triangle with the x-axis. Use the triangle given. Okay, the next problem says the angle alpha in standard position has a terminal side that passes through the point 80. So we'll call this the point 80 out here. We want to know these trig values for this. So we want to know the sine of alpha. The answer is 0 here, and the reason why is we're looking at the unit circle basically, and it doesn't matter that this goes out 8 up 0. We're talking about the angle, and the angle is 0, so you know that the sine of 0 is 0. Okay, the cosine of the angle 0, which is what this angle really is is 1. So we're talking about this point right here, which has the point 1, 0. So then we can find tangent. Tangent's opposite over adjacent, or sine over cosine, which is 0. Cotangent would then be adjacent over opposite, or cosine over sine, which is 1 over 0, which is undefined. Or I and F is what they want us to enter for that. And then secant is 1 over cosine, so it's 1 over 1, which is 1. Cosecant's 1 over sine, so that's 1 over 0, which is undefined. Okay, the next